Hi, this is the 2018 question 5 on Fourier series representations. Part A is only worth 6 marks and it says sketch the function f of t which has 3 separate values: 0 when t is between -2 and 1, t when t is values between -1 and 1, and 0 when t has values between 1 and 2. Given that f of t plus 2 equals f of t plus 4 equals f of t. And this means that every 4 units of time, the pattern repeats itself, i.e. that the period of this wave function is 4. On the domain, -4 to 4. So on the domain means along the t-axis, which would be the old x-axis, but anyway, it's along the horizontal axis. And is the function odd or even? So I've also written down the Fourier series transform, or the Fourier series equation. So the first thing then we have to do is sketch it, right? So if I just draw t along here, the t-axis, it has to be in the domain -4 to +4. But I think I'll just do it from -6 to +6, and that will probably include the waveform a few times for now. Right. Here we go. So I'm just going to roughly do this. Maybe you do this a bit more accurately. Measure these properly. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And that's the t-axis. Okay, and up this way, the f of t-axis. 0 and then -1, -2, -3, -4, -5. -6, -1, -2, -3, -4, -5, and -6. Right, so first of all, the first part we look at is you can see that this here function runs from -2 to +2. From -2 to +2. That's actually 4 units of time, which is the periodic time. So we're going to be drawing one complete wave function that we're then going to repeat. Righto, so when t is between -2 and 1, the function has a value of 0. So it's 0 from -2 to 1, just from there to there. Okay, now the function isn't exactly equal to 2, it's just greater than 2. So for that, because it's not exactly equal to 2, we use an open dot or a hollow dot, and then there, because the function is 0, along there up to the point 1, and it also equals 1, so I can do that as a solid dot there because it has the equal symbol, less than or equal to 1. Then the next section is f of t equals t when t is between -1 and 1. F of t equals t. If I write it down here, f of t equals t. Now it's only ranging from -1 is less than t is less than or equal to 1. This is a straight line because t has only to the power of 1. It's not squared or cubed. So we only need 2 points. So if I let t equal -1, then f of -1 is going to equal -1. And if I let t equal 1, then f of 1 will equal 1. So basically our values are between -1 and 1. So when f of t, when it's -1, when t is -1, f of t is -1 there. Now, according to here, t isn't actually equal to -1, but it's really, really close to it. So we will do that as a hollow dot. And then when t equals 1, it goes up to a height of 1. And it says less than and equal to or equal to 1. So we have that as a solid dot, and it goes through the origin, and it's a straight line, and you should draw it with a ruler. Okay, and then the next section of this is between 1 and 2 for values of t on the x-axis between 1 and 2, and the height of the function is 0. Again, it's a hollow dot here when t is 1, and then your solid line, and then a solid dot because t does actually equal 2. And this is the function that we will repeat and repeat. And you can see this is a hollow dot here, right? This is a solid dot, this is a hollow dot, this is a solid dot. So we don't have two y values for an x value. So now I just repeat this function. So we're going to do to there with a solid dot, and then down here a hollow dot, up through 4, and up to solid dots here. Here we do another hollow dot, that's a solid dot there, hollow dot, straight line, and we would have another one going on, and then it's start off again there. Go back, so we have back to here, hollow dot, up at a height of 1, solid dot down through -4, and a hollow dot down here corresponding to 5, and a depth of -1, so a wee bit low. And these should all be parallel. This here should continue infinitely along the t-axis. So what we have to do now is decide, is this an odd or an even function? So an even function is symmetric along the y-axis, meaning that you could fold over from one side of the page to the other side. If I folded this page over, the function, the pattern would land on itself, and it wouldn't. That wouldn't happen, because if this here was to be mirrored, it would be there. So it's not an even function. Is it odd? So for an odd function is symmetric about the origin, meaning that if I was to take this point to here and then reflect it, it would land to here. Yeah, it is symmetric about the origin. You could even test it with one of the more distant points. This point here, that distance and that angle should lead down to this one. That distance and angle is the same as that. So this is an odd function because it's symmetric about the origin. It's an odd function. It's not even, but it's an odd function. Fn short for function. Symmetric about the origin. Okay then, but now because we know one of the reasons of drawing this here is and finding out it's an odd function, it means that we can eliminate some of these values here, the Fourier coefficients, the a0, a-ends and b-ends, right? If a function is odd, we will use the b-ends. If it's odd, these a-ends here are equal to 0. And this one here, the a0 here, gives the average height of the function. Basically, it could be like the direct current value of a waveform. In this case, our average value is 0. This is -1 up to 1, -1 up to 1, and in between it's 0. That -1 averages out with the 1 here. So our average height on this here function is 0. So a0 equals 0. a0 equals 0. The a-ends equal 0. And the b-ends are what we have to find. Okay, so then we have to find a formula for the b-ends. Now there are a few formula here, and the best formula for the b-ends that I'm going to use is this one here, between t over 2 and minus t over 2. That means basically now t is a periodic time, so that will be 4 over 2 here and minus 4 over 2 here, which is basically between 2 and minus 2. That's great because this is what we've been given between -2 and 2, -2 to 2. So we will do that formula. Another thing I want to say as well is that we were only asked in the domain -4 to 4. So you should probably just label your domain like something like this. So you see, there's the -4 up to 4. That's the area there we were asked for. Just do it a little bit further so I can understand it or see it, or maybe helps identify if it's odd or even. Right then, so now the next part of the function is to actually do, we've done it, we've sketched it, we've said that it is an odd function, which leads us to know that we need to find the bn values for the second part. So the second part of this here is to find the Fourier series representation for this function. So now we know a0 is 0, an is 0, and all we have to find is the bn. So the formula for the bn that I'm going to use is 2 over capital T, where capital T is the periodic time, with the limits t over 2 and minus t over 2 of f of t sine 2n pi t little t over capital T dt. Right. So now I'm going to put in capital T at that value of 4 because we know that the periodic time is 4, and that will become 2 over 4 on the integral between 4 over 2, which is 2, and minus 2, f of t sine 2n pi little t over 4 dt. and that will cancel out and we'll have n pi t over 2. Right, so that's great. But if you look at our function here, we're given 3 different values and 3 different limits. So we will have to do the integration, 3 integrations, 1 for each limit here. Okay, so the first one is the they're written here, right? So I can write it again as Bn equals the integration between -2 and -1. That's here, of 0. F of t is equal to 0. I'll write the whole lot out, sine n pi t over 2, using this here. Okay, dt, plus the integral between -1 and 1, -1 and 1. And in this case, f of t is equal to t times sine n pi t over 2 dt. And then plus the last limit, set of limits between 1 and 2. And that's 0 sine n pi t over 2 dt. And I can say that's 0 because this here, f of t is 0. So just check -2 to -1, -1 to 1, 1 to 2, and the range is from -2 to 2. Grand. That's 0, that whole thing is 0. This is 0, that whole thing is 0. So this is all we have to integrate. So I can now say Bn equals the integral of this. And this is by parts. So I'll forget about that part, save space. So this is a by parts integration, and that's the integral of u dv equals uv minus the integral of v du. This is the formula we're going to use. So I can say let u equal t, then du dt equals 1, which means du is equal to dt. So the next part, the dv, so that means that dv is going to equal sine n pi t over 2 dt. But from the formula we need v, so v is the integral dv, which is going to be the integral of sine n pi t over 2 dt. And that will give us, if you integrate sine, you get minus cosine n pi t over 2, and then we divide the whole function by what's multiplying the t, n pi over 2. But we're dividing by a fraction, so we can turn the fraction upside down and multiply, so that will become minus 2 over n pi cosine n pi t over 2. So that's v. Now we can put this together into an equation. So Bn now equals uv t times all of this. So I can write that as minus 2t over n pi cosine n pi t over 2. That's uv. Minus, from the formula, the integral of v, which is this, minus 2 over n pi cosine n pi t over 2 times du, which is just equal to dt. Now the limits minus 1 and 1 apply here, so I should put them in. I can put them in easily there. 1 and minus 1. These are t values, the values of t. So if I was to tidy this up, this one could be, I could bring the 2 over n pi out, and it will be t cosine n pi t over 2 between 1 and minus 1. Minus times a minus gives plus 2 over n pi, and then we integrate cosine, you get sine n pi t over 2, but we also have to divide it by the 2 over n pi, which means I multiply it by 2, which makes that 2 squared over n squared pi squared. And that is going to be between 1 and minus 1 as well. So that means if I put 1 in for t now, I will have 2 over n pi on 1 cosine n pi over 2 minus, because I'm subtracting the limits, and then I put in minus 1 for the t. I forgot the minus there, that minus there, minus, right? Minus 1, and then cosine n pi, well, if t is minus 1, that's going to be a minus n pi over 2 that's this one here. So I could tidy that up a bit, leave the minus 2 over n pi out here. The minus times the minus, that will become a plus. And cosine of minus an angle, write that over there, cosine of minus x is the same as cosine x. So it doesn't matter if it's minus or not, I can just drop that minus. And I now have 2 cosine n pi over 2. Okay, then plus 2 squared, which is 4 over n squared pi squared. When t is 1, that's going to be sine n pi over 2. When t is minus 1, so we'll have a minus, and that will be sine minus n pi over 2. When I put in minus 1 for t in there. But also note that sine of minus x is equal to minus sine x. So I can bring that minus out to here, and that will become a plus. So now we're left with minus 2 over n pi times 2, make that a 4 cosine n pi over 2. And then plus 4 over n squared pi squared. These now, because that comes out, that minus makes this minus a plus, and we'll have 2 of these sines times 2 multiplied by 2 sine n pi over 2. Okay, I forgot from the very beginning, I forgot about 2 over t, which would be 2 over 4, 2 over 4, 2 over 4, here, 2 over t, which makes that a half. So this should be a half the whole way down on all of this. Bn equals a half on all of this. Bn equals 1/2 on all of this. And Bn equals 1/2 on all of that, because I forgot to put it in. So now Bn equals 1/2 on all of that. This here is very, very easy to forget, that part there, when you start getting into it, right? So I've brought it the whole way down now. So I can cancel this out, and I will have Bn equals, a 2 goes into that, and that will be minus 2 over n pi cosine n pi over 2 plus 4, 2 4s are 8, but it's divided by the 2, so it just stays 4 over n squared pi squared sine n pi over 2. And that's the Bn. Okay, well, not quite. That's a lot of work, but you're still not finished, because we have to sort out when n is 1, 2, 3, 4 and try to get a pattern out of this. Right, so I'm going to rewrite out this thing again and put in the values for n. So Bn equals minus 2 over n pi cosine n pi over 2 plus 4 over n squared pi squared sine n pi over 2. Okay, well, I'll separate these into 2 separate sections. Right, I could tidy this and it'll become this section here, right? It'll become minus 2 over pi times 1 over n cosine n pi over 2. I'm doing this just to identify the n's, right? And this one here, it's going to be 4 over pi squared, 1 over n squared multiplied by 1 over n squared times sine n pi over 2. Now, to make this easier for me, I generally draw a cosine wave. So a cosine wave starts and goes like that, right? That's the cosine wave, and cosine, and the sine wave. The sine wave starts at 0, 0. It should be the same height, but whatever. That's at a height of 1, and it goes down to minus 1. That's at a height of 1, and it goes down to minus 1. But the main part is, that's a full wave to pi. That's pi. This is pi over 2. This is 3 pi over 2. This is 5 pi over 2. And the next thing here would be 6 pi over 2. That would be, right? Here's 0, 0. Full wave here, that's 2 pi. Therefore, that's pi. This is pi over 2. 3 pi over 2 has a value of minus 1. And 5 pi over 2 has a height of 1. So now when I say let n equal 1, right, and I just do the cosine part, that will become minus 2 over pi times 1 over 1 times cosine 1 pi over 2, which is pi over 2, which is 0. This is 0, so the whole thing is 0. When n equals 2, it's going to be minus 2 over pi times 1 over 2 times cosine 2 pi over 2, which is cosine pi, and cosine pi is minus 1, so we will have minus times a minus, so we have that minus 1 times a minus 2, which will give us 2 over pi times 1 over 2. When n equals 3, it will be minus 2 over pi times 1 over 3 times cosine 3 pi over 2. 3 pi over 2 is 0, so this whole thing is 0. When n equals 4, it will be minus 2 over pi times 1 over 4 times cosine 4 pi over 2, which is cosine 2 pi, which is equal to 1. So we will have minus 2 over pi times 1 over 4. When n equals 5, it's going to be 5 pi over 2. That's going to be 0. When n equals 6, it's going to be minus 2 over pi times 1 over 6 times cosine 6 pi over 2, which is going to be minus 1. And that will be a minus times a minus will give us 2 over pi times 1 over 6. So the only things of value with this cosine section we have are 2 over pi on 2 over pi and a half minus 2 over pi and a quarter and 2 over pi and a sixth. 2 over pi and a half minus a quarter plus 1/6. So then the next one's going to be minus 1/8 and so on. Now, I can tidy this here up now because I can see a pattern with the n's. This is the new n equals 1, n equals 2, n equals 3, n equals 4, and so on. You can see the values here. In the fractions, the denominator is twice the n value. That's 2n, 2 2's are 4, 2 3's are 6. So I could really summarize this part of the bn, the minus 2n, the minus 2 over n pi cos 2n cosine pi over 2 as this, right? So this is part of the bn, but not the whole lot of it. It's 2 over pi on the sum from n equals 1 to infinity of 1 over 2n. But it's alternating signs, minus, plus, minus. Starts with a plus, so it's going to be minus 1 to the power of n plus 1. Because the minus 1 to the power of n plus 1, of n is 1, then n plus 1 is 2, that makes it squared. Minus 1 squared is plus 1, and so on. So that's that part, right? Then the next part here, this here, 4 over n squared pi squared sine n pi over 2. Go over it again where we let n equal 1, so it's going to be written as 4 over pi squared times 1 over 1 squared times sine pi over 2. Sine pi over 2 is equal to 1, so that is going to be 4 over pi squared times 1 over 1 squared. When n equals 2, we're going to have 4 over pi squared times 1 over 2 squared times sine 2 pi over 2, which is sine pi, which is 0, 0. When n equals 3, 4 over pi squared times 1 over 3 squared sine 3 pi over 2, and that's minus 1. That's minus 1, so we now have minus 4 over pi squared times 1 over 3 squared. When n equals 4, that's going to be 2 pi, so that's going to be 0. When n equals 5, it's going to be 1, so it will be 4 over pi squared times 1 over 5 squared times 1. Right, that's that one, and so on. When n equals 6, it's going to be 0, and when n equals 7, it's going to be 4 over pi squared 1 over 7 squared times minus 1, minus. Okay, so this sequence here, this new sequence looks like, there's the first term, 4 over pi squared times 1 over 1 squared minus 4 over pi squared times 1 over 3 squared plus here 4 over pi squared times 1 over 5 squared plus dot dot dot. So you can see there's a pattern here again. So that's going to become 4 over pi squared times sigma n equals 1 to infinity. Here, well, let's see, our n terms are, this is n equals 1, n equals 2, n equals 3, and so on. You can see that 3 squared is going to be 2n minus 1. 2n, that's 2 3s are 6 minus 1. Yes, 2 2s minus 1, 2 2s. Oh yeah, it's n is 2. So we'll have 2 2s are 4 minus 1 is 3. N is 3, 2 3s are 6 minus 1 is 5. N is 1, 2 1s are 2 minus 1 is 1. So it's going to be 1 over 2n minus 1 squared. But again, the signs are flipping. Plus minus plus minus, that'll be minus 1 to the n plus 1. So now I have the bn term. I can put these two things together for the bn term, and bn is equal to 2 over pi sigma n equals 1 to infinity of minus 1 to the n plus 1 over 2n plus 4 over pi squared sigma n equals 1 to infinity minus 1 to the n plus 1 over 2n minus 1 squared. Now it's nearly done, because all we have to do according to the formula now is multiply it by, let me see if I can show you the formula sheet. Multiply the bn by the sine 2n pi t over t. We know that that was 0, and we know that that was 0. So now I can finally write that f of t equals f of t equals bn, well, the sum n equals 1 to infinity of bn sine 2n pi t over capital T. And the a zeros are 0 because the average height of the function is 0, and the a n's are 0 because the function is odd. And we're just left with the bn's. So now f of t equals, so our bn's are 2 over pi sigma n equals 1 to infinity minus 1 to the n plus 1 over 2n times sine 2n pi t over capital T, which is 4. Okay, and then the other part plus 4 over pi squared sigma n equals 1 to infinity minus 1 to the n plus 1 over 2n minus 1 squared times sine. And this case here, 2n, the n is actually equal to 2, so that will be 2 times 2n. And here the n is equal to 2n minus 1, so it's going to be 2 on 2n minus 1 pi t over capital T, which is 4. Okay, so I can tidy that up, and that will become 2 over pi sigma n equals 1 to infinity minus 1 to the n plus 1 over 2n sine 2 2's are 4, which cancels with that 4, n pi t plus 4 over pi squared, the summation n equals 1 to infinity of minus 1 to the n plus 1 over 2n minus 1 squared sine, that 2 will cancel with the 4 and give you 2 underneath, 2n minus 1 pi t over 2. And that is your first year's transform for that signal. That's the answer. Finished.